straight line graphs. So let's get our heading down and learning objective for today, perpendicular lines. Hit pause when you're ready, hit play again. So I'm hoping that you remember everything you learned about perpendicular lines. Now if you have two lines, let's sketch two lines here, a red and a blue line. We can find the gradients of these lines by finding the rise over the run. With the red case here, we've got a positive gradient, so it's 2 divided by 1, which gives us 2. With the blue line, is a negative gradient, and the rise is 1 over 2, but because it's a negative gradient, you have minus a half. So in general terms, we can say that if the gradient of a line is m, if the gradient of a line is m, then the gradient of its perpendicular is minus 1 over m. So we can that gives you an idea of what we're looking at today. We can also state it as if two lines are perpendicular, I'm going to do perpendicular like that. Two lines are perpendicular, then the product of their gradients is minus 1. So that means if we have m and we multiply it by minus 1 over m, that's going to give us minus 1. Okay, so you can make some notes here. I'm just going to put a blue line through the m's to show that they cancel each other out, to give us that minus 1. So that's what we mean. So basically, when you have two lines and they're perpendicular to each other, the gradient of one is going to be m, and the gradient of the other is going to be the negative reciprocal. Okay. Hit pause, make some notes. When you're ready, let's have a look at an example then. Okay, so this example we got here, let's write example. Are the following lines perpendicular? Are they perpendicular? How can we tell if they're perpendicular? Well, if they're perpendicular, then the products of their gradients is going to be minus 1. So if we find their gradients, then that can help us then. So if we take equation 1, what's the best way to find its gradient? We've got 3x minus y minus 2 is equal to 0. Well, if I make it y equals mx plus c of that form, then I can read off the gradient. So I'm going to take the y over to the other side. We just change color if I'm going to circle it. Let's go blue. So I'm going to take my negative y across the equal sign, which is going to make it positive on the other side. So that means I've got 3x minus 2 is equal to y, or y is equal to 3x minus 2, which means the gradient, therefore the gradient of equation 1 is 3. And then let's take equation 2. Now that's x plus 3y minus 6 is equal to 0. I'm going to do the same thing, but this time I'm going to keep my 3y on the left hand side and put my my x term and the number on the other side. So 3y, oops, let's just circle that, it's going to go over there. Same thing with the x, and the x is going to become negative and the 6 is going to become positive. So that leaves me with 3y is equal to minus x plus 6, and divide by 3, I get y is equal to minus a third of x plus 6 over 3, which is 2. So the gradient of equation 2 is minus a third, which means that the lines are perpendicular. Therefore, the equations are perpendicular. Tell you what, it's better if we say lines. Oops. So let's have a look at this example then. Are the following lines perpendicular? So we've got, let's just label them so it's easier to talk about them individually. Call that one 1, call that one 2. Now to find the gradient of a line, if I set it out as y equals mx plus c, then I can read off what m is. So if we take equation 1, that is 3x minus y minus 2 is equal to 0. If I set it out as y equals mx plus c, to do that, I'm going to try and keep the y positive. So I'm going to float it over the other side, and the minus y becomes a plus y on the other side. Go back to red. So that gives me 3x minus 2 is equal to y, or y equals 3x minus 2. That implies then that the gradient is equal to 3, which is just next to the x there. Let's look at the equation 2. Let's find the gradient on equation 2. Take equation 2. We've got x plus 3y minus 6 is equal to 0. This time I'm going to keep my y on the left hand side. I'm going to take my x and float it over the other side of the equal sign. Same thing with my minus 6, which will become plus 6 on the other side. Let's just go back to red. There we go. So that means 3y is equal to minus x minus 6. And then I'm going to divide through by 3. So that leaves me with y is equal to, if I divide by 3, I get minus 1 over 3, or minus a third x. Oops, that's a plus 6, isn't it? Plus, and 6 divided by 3 is 2. So the gradient is equal to minus 1 over 3. So that means that, therefore, the lines are perpendicular, as 3 times minus 1 over 3 is equal to minus 1. And I'll just use the blue pen to cancel the 3's out. 3 over 1, and the 3's cancel, so you got minus 1. Good. So hit pause, make some notes, and when you're ready, hit play again. So let's have a look at this example. Are the following lines perpendicular? So if we call them 1 and 2, as we do, let's take the first equation then. You can read the gradient from that straight away. Y equals a half of x. So the gradient is equal to a half. Now, if the second line is going to be perpendicular, then its gradient must be minus 2. So let's have a look and see if it is. So take equation 2. You've got 2x minus y plus 4 equals 0. Let's take the y over to the other side where it becomes positive. So when we do that, we've got 2x plus 4 is equal to 0, is equal to y, or y is equal to 2x plus 4. The gradient is equal to 2. Now if we multiply them, a half times 2, we get 1. So the lines are not perpendicular. Not perpendicular. Good. So hit pause, make some notes. When you're ready, hit play, and we'll have a look at another example then. Okay, in this example, we've got a line perpendicular to the line 2y minus x minus 8 equals 0, passing through coordinates 5 minus 7. Find the equation of the line. So we're going to find the equation of a line that passes through this point, 5, 7, passes through there, and is perpendicular to this line. So if we find the gradient of this line, then we can also find the gradient of its perpendicular. So we've got 2y minus x minus 8 is equal to 0. So I'm going to make y the subject. So I'm going to take my minus x over the other side of the equal sign, becomes plus. Same thing for my minus 8. Take it over the other side, becomes plus 8. So back to red, that means 2y is equal to x plus 8, and then divide by 2, which will give me y is equal to a half of x plus 8 divided by 2, which is 4. So the gradient is equal to a half. Therefore, what's the gradient of the perpendicular? The perpendicular is going to be equal to the negative reciprocal minus 2. So let's draw a line here, and then let's see if we can work out the equation of the perpendicular line that passes through the point 5 minus 7. So find the equation of a line and gradient minus 2. I use my formula. Y minus y1 is equal to mx minus x1. So I've got the coordinates x1 and y1. So if I plug that in, y minus 7, minus minus 7 is equal to m, which is minus 2, x minus 5. Expand and simplify, so that becomes y plus 7 is equal to minus 2x plus 10. And general form, let's see, we can write this as y equals mx plus c, so y is equal to minus 2x plus 10, and let's just use a blue pen to quickly float this plus 7 over the other side where it becomes minus 7. I just want to go back to red, and so it's minus 7. So y is equal to minus 2x plus 3, which is fine. You can write it in the general form of ax plus by plus c equals 0. So you can say, bring the 2x back over this side, 2x plus y minus 3 is equal to 0. And just for completeness, let's just show these two going back across the equal sign, where they change sign. And in red pen, so either of those, y equals minus 2x plus 3 or 2x plus y minus 3 equals 0 is the equation of the line. So hit pause, make some notes, and when you're ready to move on, hit play again. And your exercises. Exercise 5F, I'd work down the left hand side of the page to get into the wordy questions, and off you go then. You've only got 12 questions. Enjoy.